There's no way I'm about to hold flowers in
All right, here we go.
4 hours.
Number 9. You got paper in front of you. Try to do this on the pink, it will be a disaster. So 9. Battery is at 12%. I think we're okay.
Your performance was immaculate the other night.
I was literally in tears.
Hey, Matt.
You're very kind. Dancing is not my strong.
Hey, that's okay.
Do you have a video of it?
I do not.
Yes. Did your wife come?
No, she wasn't. My true hidden aspiration is I want to be a good enough drummer I can be in my son-in-law's band, but dancing is not my thing.
I feel like it actually is.
You're too kind.
What's your favorite drum?
My favorite drum? I like the drums.
What's your favorite one to like just drum like?
I played in the snare line in high school, but that's been a long time. So,
Oh, you play drums?
I played in the snare line in high school. We actually had a really good drum line. And I did drum set a little bit in junior high and haven't really done it since. So like, I can sit down and do the basic beat to a lot of songs, but I'm not good at fills and things.
That's awesome.
It's fun.
Calculus teacher by day, drummer by night.
My son-in-law is really good on the guitar, like really good. He's super fun to play with because you just listen to him and you think you're really good.
Yeah.
I'm not, but it sounds like I think you are. We're talking on the video. That was a real big waste, but whatever. Okay, here we go. The goal is to find the antiderivative of this formula right here. And we talked last time, the only way to find an antiderivative is with a formula. There is no other method. Like you have to use one of the formulas on that blue sheet, or you have to go get a textbook or get on the internet and find a formula that will work. So for our class, unless you want to memorize more formulas, the blue's it. If it isn't one of those, you can't find that antiderivative. So there is no formula on the blue sheet that even remotely resembles what we are looking at here. Because the blue sheet formulas are all simple. Like we have x to the n. This is far more complicated than x to the n. You could use the extended version of the blue formula. But that doesn't really help either because the extended version is just an expansion of the basic version. Like the basic version looks like this. The expanded version simply replaces every x with ax plus b. So that doesn't fit either. So for our class, if there is not an available formula, your very next method you must use is a technique that is officially known as finding an antiderivative using a substitution. It's a lot of words, so most teachers just say, we're going to do a U substitution. It could be a W substitution, but the grammar is much more interesting if we use the word U. So, comments? Yeah, there you go. Got several references here. There's one way up there. There's one right here. So, you've seen the movie The Help. This is a really good reference, actually. Anybody seen the movie The Help? That's a really good movie. That's really good. Yeah, I like it because several years ago, that movie was more popular, and I was talking about U substitution, and two girls like, yeah, like the movie. He was smart, he was kind. All right, here we go. So to do a U substitution, here's what you're going to do. First of all, you have to use a specific notation because the problem is the most complex problem we have done to date. We have not done anything that is this level of complexity. And if you don't lay it out how I lay it out and you ask for help, I'm not going to help. It's too hard. It's too hard to like dig through your mess of work and go, okay, I can kind of see what you're doing. But if you follow my kind of formatting, then it's easy to find your mistake. So we work the problem straight down the page as always. But U substitution requires that we do some work over here on the side. So come over here. And it will take nearly the entire page to solve this problem, so be prepared for that. All right, so first thing it says right here, now this is like Pirates of the Caribbean. These are more guidelines than they are rules, okay? They work really well, but once in a while you'll see me deviate from the guidelines. And don't be shocked, just say, okay, remember they're just guidelines, you can deviate somewhat and it still may work. But it's a really good place to start. We need to find two functions that are being multiplied. So, I can rewrite this like so. Antiderivative, x over 1 over square root 3x squared plus 5. And now I can see that I have two functions being multiplied. It is possible sometimes to do a u substitution when one of the two multiplying functions is nothing more than a constant. So that's also possible. Pretty good. Cool. Okay, so we got this part done. Now it says both functions are of the form we see here. So we'll go to Adam. You got 1, 2, 3, 4, 5. The yellow function is of which form?
I don't know the first one.
It's the first one. It's something. Adam, what's the something? X. To a number, what's the number? 1. So the yellow function is of the first form. So that's good. That's what we wanted. 2 points for Adam. Cool. So we'll go to Simon. Nope. Next question. Sorry, I haven't even asked a question yet. That's like on the ball, man. So Simon.
There you go, Simon.
The purple function is of which form up there?
3.
Good. It's 1 over something. 1 over something. 2 points. So that part's good. Item D is just a way to help you memorize. The 5 forms match the 5 rules, almost. The rules are more specific. The rule says x to the n, e to the x, 1 over x, sine of x, cosine x. The forms say something to a number, e to the something, 1 over something, sine of something. So the forms are more flexible, the rules are very specific.
On the antiderivatives rules, it says that n cannot equal plus or minus 1. So how would that work with x?
So what that's saying is you're looking at the expanded version. No, you're looking at, I guess, just the expanded version, yeah? Right here. Here's why that note is there. Oh, that's not the expanded version, hold on. So the expanded version looks like this. Now let's go find it, hold on a second. It's gonna take too long.
Oh wait, it can't because the power rule, if you do it opposite, it would have
Or would be divided by
If you had a -1, you'd be dividing by 0. If you have a positive 1, the reason it says don't use a positive 1 is not because it's illegal, it's only because it's unhelpful. It makes the problem harder.
Okay.
So like here's the expanded version. Let's copy that over. We're on number 9, yes? So if we copy that. If the n is 1 in the expanded version, all you really want to do is use the add subtract rule and just do these antiderivatives separately. It's a lot easier. That's all. It's not wrong, it just makes it harder. Does that answer your question?
Yes.
2 more.
Why are we using the expanded power rule right now?
We're not. We can't. There's no way to use the expanded rule because we don't have this 2 for granted. We do not have this in front of us, right here. That's not sitting in front of me, so I can't use it. Please.
So the expanded ln rule, that looks pretty similar to the 1 over square root, but since it like kind of varies a little bit, you can't use it, right?
Everyone listen to Lucas. He's going to get a ticket for this. No, you said it really well. The rules on the blue are not flexible at all. Like it must be a letter for letter, character for character match. So you're right. When I look at this purple here, I'm like, okay, 1 over something, definitely of the correct form here. But if I'm trying to make that match the ln rule, it's not even close, because the expanded version of the rule says you can have 1 over ax plus b. So here's all the problems we encounter. The rule doesn't allow for the root. The rule doesn't allow for x to be squared. So 2 reasons why it doesn't match. Does that make sense? That was good work. Anybody else? Cool. Okay, next thing. Item E. Item E says we're supposed to pick u to equal the something. Here's what I mean by that. Let's go back to Lucas Harris here. In the yellow function, we said that was of the first form. So what was the n, Lucas? 1. And what was being raised to the 1? X. So x is the something, n is the 1. It says over here, 2 for Lucas, we're supposed to pick u as the something. So you write on your paper, u is equal to the something, which is x. This is where the grammar gets fun. So u is x. Questions?
Question before, if both of those parts like aren't of that one of those forms, then you just like keep working at it, or is it?
Good question. For our class, they'll either give you an antiderivative where you literally can see that it matches one of the formulas, either the regular or expanded versions. So just use the formula. Second thing that will happen is u substitution will be possible, meaning pretty high chance it's going to follow this sequence. We might encounter a few where I've got to be a little more creative, but not usually. Third option is you've got to do just some algebraic manipulation to make it match this sequence or match a formula. And there's no other options for our class, just 3. If you were taking BC calculus from memory, I took this class a long time ago, but like you would have about 7 or 8 options to worry about.
What?
But for this, only 3. So it helps. Okay, cool. All right. Notice, look. Okay, if u is truly equal to x, which would be the appropriate choice based on what we've talked about, that's not a choice that is useful. Because all that's going to happen is if I make a replacement, I take every u and put an x in its place, the problem will look exactly how I started, except that it'll say u instead of x. So this is not good news. So we do not want to do that. Please.
So don't write that?
Whether you write it or not, I don't care. You just have to notice that if u is going to equal x, that substitution won't work.
Okay.
So I don't need to worry about it. It's not going to help me. But I want to point it out so you understand that it doesn't help.
Wait, why won't it work? I don't know, like,
If u is equal to x, that's a good question, 2 for Nathan. When I go back to here, and everywhere I see an x, I put a u, the problem's identical. It didn't change. So it didn't help anything.
So then why do we write?
Oh, because we have 2 choices for u. This is the wrong choice. Now I want to see if we can find the right choice.
When would that ever be?
So the other one would be
Never. This will never be the right choice.
Why'd
So
you
why do we have
say
2
it?
choices then?
Then why do you have to list both choices?
Oh, just so you can see that there are 2 choices. You can see that one doesn't work and one works.
You'll never use this form.
You've got a choice, but you really don't.
Will one of them always
That's
be?
true.
Will one of the choices always be you?
Ticket.
Not necessarily. What he just said is accurate. Listen.
You have to list.
Just because in this problem one of the choices is u equal x doesn't mean it's always.
You don't have to list it.
That is correct. Please, Clara.
Does it not work because of the dx? Because that would be a dx.
No, the formula would completely convert to this. You'd have u over square root 3u squared plus 5 du, which is an identical problem. So it just didn't get us anywhere. 2 points.
So you're saying there would be some scenarios where they would change it to you, or like?
No, what Nathan Rumler said was there could be scenarios where one of the choices will not be u equal x and the other choice won't either. And then you gotta figure out which choice is the right choice. That's where we're at. So we need a second choice now for sure. Here's how you find the other choice. So Henry will help me. So Henry, look at the other function. We looked at the yellow already, now we're gonna look at the purple.
Yes.
So looking at the purple, what form does the purple have, Henry? Form 3, 1 over something. U is the something. So what would U be for that choice, Henry?
Equal square root of
Good work. 2 points for Henry. Okay, so that's better than u equal x, so at least so far so good. No smiley face yet, to be honest, but. Pretty good. Next step says differentiate both choices. We didn't need to do this one, we already know it's not going to work. It's funny how you think that's so weird, whatever. So differentiate both choices. So we do this. We apply the ddx operator. Nathan Kimball will help me here. That side can't really do much, it's just du over dx. This side has more potential. So the right side can be written differently. The left side cannot.
all the derivative rules.
Yes, you do.
Oh, yeah. I'm not.
Because I told you on August.
1/2.
I told you on August 18th.
It's 1/2.
This is not the class where you learn discharge, learn discharge, learn discharge. Have a final at the end of the year where you just have to kind of go back and learn the really easy problems and then do them on the final and get an A. This is not like that at all. This is a very integrated
Wait,
class.
it's 1/2
Funny.
3x squared plus 5.
What is it? Go.
1/2 square root of 3x squared plus 5. Right? And
going.
then d of 3x plus or 3x squared plus 5.
Nice, sit down. 2 points.
Oh, wow. It's like I did a test. And actually paid attention.
Yeah.
And picked up.
So, back to Nathan Kimball. So what's our, so this is du dx. So in more simplified terms, what is du dx equal?
Don't you have to have like the 6x on top?
Good. But the 6 will divide with the 2, leaving just a 3x on top. And on the bottom we'd have the root. 2 for Nathan. Questions? Every watch, don't miss this, don't miss. Okay, you have to determine whether that's a good result or not. Here's how you know. We'll go to Will.
Yeah.
So Will, this choice of u was made based on the first multiplying function or the second?
The first multiplying function. Wait.
I'll say it again, you're good. It's a long question. This choice of u,
Yeah.
did we make that choice by paying attention to the first multiplying function, which is this item in yellow?
Oh no, the second one, of course.
Second one, good.
Of course.
So we made the choice, listen close, listen close. So we made the choice based on the second. We took the derivative of our choice.
Why?
So far, just because I'm telling you that's the process, so just hang tight for now. Look, we found that the derivative of our choice, right here, is equal to that thing.
Uh-huh.
Okay, this will sound like a dumb question, but just answer it so I can keep interacting, it helps. Is the derivative of our choice an exact copy of the first multiplying function?
Absolutely not.
Absolutely not.
Where's the assert?
2 points for Will.
He's feeling it
Good
today.
question, dude. I was like, wait, wait. Give me something.
Is it fair to say, like, maybe trick is the wrong word, but like I don't like to put you on the spot, make you feel uncomfortable. So I say, well, it's kind of a trick, so just so you're on guard. They're like, yeah, they're different.
Yeah.
It just helps to hear you say it. So good?
So it's
Must always be different?
Ah, watch this cool. Watch how cool this is.
Watch this.
Watch this.
Watch this.
Watch this.
cool, guys.
Watch
So it has
this.
to be the same for BF smiley face.
Yes.
Okay.
It can differ in that they can have
Draws a
different.
frowny face.
Is this what plus
What
three
you
is?
did.
Was that?
Is this for season?
That's awesome.
Not yet. No C. No C. Hey, look.
When are we gonna be happy?
It's because the smiley face looks like a U.
Funny.
Wow.
He gets it.
Oh! 2 tickets.
Oh.
No one's ever said that.
So clutch.
17 years of teaching calculus. No one's ever said that.
What can I say? I'm original.
I like him. We need a sign, man. We need a sign.
Because this.
Now you gotta make a sign.
I got it.
Gotta make a sign. Nathan Rumler.
That's your homework
You can
assignment.
get the whole family to sign it. Like the Rumler family sign.
Let's sign it.
Okay.
Yeah, I can get all the way 3 siblings in.
Listen, come back, focus, come on, look. For this method to work, you make a choice of u based on how I told you to choose u. Once you've made that choice, the derivative of your choice must match the other multiplying function. It can differ by a multiplying constant. Math word for that is a coefficient, okay? I don't really like that one. Multiplying constant. A multiplying constant can be different. But like Will said, this isn't even close to that. This isn't x. It's a mess. So that's a bad choice. So we need to make another choice. So we go back to Ryan's question, like, what do we do? Well, we've got to do something algebraic that will give us the opportunity to make a different choice.
Make you something else.
Right.
We're changing you.
See, the grammar here is just awesome. To make you something else, we're changing you.
Mr. Smith, I
We're
choose.
going to be a new man. All right, new woman. Okay, look.
Oh, x squared, the square root of x squared.
Well,
Something,
but you
right?
gotta think.
Oh, hey,
And then, so you gotta maybe do something with that.
so do this.
So you're telling me all that was just a waste
Actually, I
of time?
take it
No.
back because it's x squared.
Because
All these choices are actually.
is your goal, okay, is your goal to be prepared for a test where you know every question ahead of time?
Yeah, but no. I wish. But when?
I wish is a fair comment,
when-
but are you preparing for a test for which you will know every question ahead of time?
No.
No.
No, sir.
So understanding when a roadblock will occur and how to get around it is of great value.
Well, when will it be like that? When will?
When will this happen?
You be correct. Yeah. When will like?
Let's
the
go back.
world.
Let's go back. Watch. Here we go. So raise your hand, please. Everyone in the whole room who can say they understand what I just wrote on the board.
Oh, dang it. Oh, crap.
Oh.
You're just on me. Okay.
Oh.
Hands up. Who understands what I just did?
Power on high, roots down below.
2 points for everybody in the room. Just wanted to make sure that's 2 for everybody, whether you voted or not. All I did was remember that square root means 1/2 power. 1 over something to a power is the same thing as same something to -1 times the power. But what I just did, Sarah will help me, is something dramatic happened. Sarah, the first multiplying function, did the form change or stay the same? Stay the same. Sarah, the second multiplying function, did the form change or stay the same? Changed. What form is the green function now?
It's the same form.
What is it? Yeah, it's the first one.
Is that why it says? Is that why B is both functions are of the form?
Both functions were of one of those 5 forms originally.
Oh, so that's what.
The second case, both functions are still of one of the 5 forms, but we were able with some algebra to change the form of the second function. And Sarah correctly said too for her, the second function is now of the form something to a number. So Reese, what's the something, what's the number? So we're looking at this one. What's the something, what's the number?
The something is 3x squared plus 5, and the number is -1/2.
Good, 2 points. Something is 3x squared plus 5, number is -1/2. No talking. Henry, please.
What did you get?
same result.
Let's try it.
So u has u equals the square root of 3x.
So I come over here and I write down, a little running out of room here. Let's move this off the board. We don't really need this anymore. So moving this away for a moment. New u.
New u. I mean.
No, no u. Not me.
New u.
New u.
No u.
Henry, what's the new u?
New u is 3x squared plus 5.
Good work.
Oh, I see.
2 points. Eliza, I take the derivative of both sides. Eliza, what's d dx of the right?
6x.
Eliza, we found a u. The u came from which of the two multiplying functions?
The second one.
The second one. We took the derivative of our choice, Eliza. Is the derivative of our choice a dead match for the other multiplying function?
We have to do it again?
Yeah. I mean, no.
It's not, but how does it differ?
There's a
Multiplying
constant.
That multiplying constant is what?
6.
What's this multiplying constant?
1.
Good. If that's all that's different, we're great.
Wait, I thought that was supposed to be for the.
Draw the smiley
It has to be
face.
for the first one.
Yeah.
So the first and the second forms has
watch
to
this.
They interact.
equal.
They got to interact. So you found the u. Hey, you want to talk? Come on. Sarah, we
Because
found
now
the
they're
u.
both under the first form.
The forms don't really matter that much. They really don't. That's not what's important. Like I can show you other examples where that's not the crucial part. The crucial part is to get it so we have two multiplying functions. We get u from one of them. The derivative of our choice must be the other.
Oh, I thought it had to be the same as the same. Okay.
Did that answer your question?
I was like, why did that?
Sarah, you good? Please.
Is there a way to like check from the beginning like which one you should try first?
Boy, another ticket.
Whoa!
It's really good.
Wow.
On fire, man.
What did he say?
Lucas, you're on the
Say
fire.
again.
Oh, sorry.
He forgot it was someone else's question.
I said, oh yeah, is there a way to check from the beginning which one to use?
Okay, watch. So I told you the rules were guidelines, right? I don't really use the guidelines because I've done this long enough, I can do it faster. So at the very beginning, here's what I would have done. I would have looked at what they gave me. I would have said, okay, it doesn't fit any rule, skip that. Then I would ask myself, Lucas, you'll help me since I paid you a ticket. Is there some expression amongst all this stuff whose derivative is another expression? And I would have said, wait a minute, right here. Lucas, what's the derivative of that green stuff?
6x.
Hey, jackpot, because that's x.
Oh, and you could just boom, boom, boom. All
If
in
I
your
see
head in
that,
10 seconds.
If I see that, then I feel reasonably confident. Like there could still be some other roadblock, but I'd be reasonably confident that the correct choice of u is right there.
Even though it has like the square root.
Right, I'm not worried about that really. I don't really worry about that. I might have to later, like I might still get stuck. I'm like, u substitution doesn't always work. This is the first method we've shown you all year where like, guess what? This might work, it might not.
Oh, wow.
So what's the value of making a match? Does it allow you to apply or rule now?
It will in a moment. Two more, please. No worries. Are you talking about, let's back up a minute. So were you okay when we were working with this, and we found two possible choices for you, and discovered neither one worked?
Neither one worked.
So u equal x doesn't work because it never doesn't help anything. Our other choice for u was right here. That was made based on the fact that the purple function is of the form 1 over something. So we always choose the u to equal to something. You okay with that?
Yeah.
So that's right here, the guidelines. We choose u to equal to something right here. Good there? Cool. But then we differentiate our choice and we find this to be the derivative of our selection for u, and that doesn't match this. So that means no good. Good there?
Yeah.
Are you okay how I changed this formula? Wrong color. How I changed this formula right here into this formula.
I was just looking. I thought you would take it from over there.
Oh, you're okay. No, all I did was say, it's a good question too for Lucas. 1 over something to a power, this is 3x squared plus 5 to the 1/2, can be rewritten as 3x squared plus 5 to the negative 1/2.
I get it.
You good now?
Matt missed out.
Don't stop asking, please.
Wait, where did the square root go?
So right here, Clara,
Yeah.
you have 1 over,
Oh, it's the 1/2 because it was
Yep,
in
good there.
Well, why don't
Yeah,
we have the 1/2 in the here?
oh, because u is the something. So Sarah, what form does this green, this is really good. It's really good Lucas brought this up because like half the room was kind of in the same place, not sure where this all came from.
Or because the 1/2 is
Look, Sarah, that's the second of the two multiplying functions. What form does that function have?
something else.
Something to a number. What's the number? What's the something? 3x squared plus 5. You always choose the u as the something. That makes sense? Answer your question. 2 more.
So what's the point? Why are we finding u? Like, how does that work with any of that?
That's the next thing to do.
So as of right now, we're not supposed to know what the u is supposed to do.
Not yet.
Okay,
No,
okay.
it's a good question. No. You keep asking. Don't stop. Eliza, please.
Like, why are we using a derivative to find an antiderivative? Like,
Yeah,
you
we're
know,
just
the-
taking a step backwards.
We're almost there as well. We're almost there as well. 2 more. Hey, look. Come on. Look. Everybody look at me. Come on. Look. No, you're in a really good place. Like, you're following really well. So far, the entire discussion has been, how do we choose an appropriate u? But there has been no information presented as to why that would even matter. I just have to start somewhere. Like, it's a complicated enough process. There's no way to really give you like the whole big picture. I just have to say, okay, start here and then we'll build on that. Are you okay?
Wait, but
Oh, please.
for our u, or for our second equation, we know it's correct
Because, so what was the u we chose? So we got to here, Sarah. We have 2 multiplying functions. We picked a u from the green function, right?
yeah.
We found that the derivative of our pick looks just like the other function, right? Except for a 1 versus a 6.
Yeah, well, that's what I was asking
Go
before,
ahead.
where it has to match, but you said that didn't match.
It has to match, other than it can be different in terms of a multiplying constant.
Well, yeah, but
Yeah.
it just has to match the form of it, right?
It has to be more than the form, it has to be the exact same thing, not the form. Like this right here must be a character for character match of this. Other than it can have a different multiplying constant. That better? 2 more?
Why can I have a different multiplying constant?
Show you in a second. 2 more. Please.
So the overall goal is to like derive the like the starting equation into matching the yellow box. We did like a bunch of
The goal is to pick an appropriate u, and the way you can tell if the u is the right choice is, did my choice for u's derivative, which this u came from the second multiplying function. Did my choice, the derivative of my choice, match the other function? That's the goal so far. Please.
So we don't actually use the derivative. The point of the derivative is just to make sure it's the right u.
2 points, but we actually will use the derivative. Yeah, that was Eliza's question. It's more than just a check. But the check is a good kind of midway point to say, okay, I'm on the right path, might as well continue. If you can't get this to happen, don't keep going. It's not gonna, you're not gonna get anywhere. Okay? But you gotta get that to happen first. Please.
Say you tried like the first two ones that we just did, and then both of them didn't work. Would there be a way to change that equation into like the sine and cosine ones, or no?
Probably not sine and cosine, not for our class. But again, there's only 3 options for our class. 1, the formula sheet will just work. 2, this process that we are learning will work. Or 3, there is some other algebraic rule you're just not remembering that you need to use. That's it. There's no other options. You're welcome. Okay. All right. Other questions? Really good. Please.
So if you looked at the original one, and you can tell like what you did with the circles, like you know that you need to do 3x squared plus 5 to make that do the derivative. Would you still want to do the square root of 3x? Because like if you found the 6x, would you still want to go back and do u equals square root of 3x?
Oh, that's a good question. I'll pay a ticket for that one, Clara. Hey, Claire said she looked up, she kind of leveraged what Luke was doing. More down. You know, Lucas said, is there a way to determine quicker? And I said, yeah, I can do it quicker every time. Once I do use this, and I say, hey, I'm pretty sure you must be this, I would never do any of this. Like I found the U. I don't need to do that. At least I'm pretty sure I've got it. So. There you go. Okay, next thing. So now that we have found U, we kind of have to restart. Like that's a fairly lengthy discussion until you get the hang of it. So let's start over a little bit. So let's copy this. Page 18, look for 19 to appear. There's 19. So we're going to erase a bunch of this so we can kind of start over. We're going to start right down here. Clear all this off. Okay, it is called finding an antiderivative using substitution. Substitution means you've got to find something that's equal to something. Here's where the cheesy story comes in. So I had a student one year who said, hey, this is just like dating. Wait, okay. Explain further. And she's like, oh, watch, it's really cool, Mr. Smith. Look. We start out up here, everything's involving X, right? But there comes a time sometimes in dating where you're like, okay, we've dated enough, I gotta move on. This isn't really progressing. It's time to move on. So at this moment, you want to start forgetting about your ex. You know, break out the Taylor Swift song, you know, Picture to Burn and all that. And everybody knows this song.
I love that song.
That's a good song. I'm not kidding. At this moment, you need to forget about your ex. Like, just forget about it. And you need to take a little break and make everything about
you. Oh, what? Jeez, you should be a songwriter.
There you go. So we're gonna go. Okay.
Applications.
Everybody kept asking, like, what is the point of all this? Look.
So forget about your ex.
Wyatt. The point is to convert an antiderivative that is using only x into an antiderivative that only uses u. But you can only convert if you can find things that are equal. So Nathan Kimball, is there anything here in this antiderivative, so all of this, is there any part of that that is equal to something involving u so we can make a replacement?
Yeah, the 3x squared plus 5.
Perfect. Start right there. So these two functions, the yellow and the green, they're multiplying. Therefore, the order doesn't matter. So I can switch the order. So the next thing you write on your paper, too, for Nathan, you write equals, you write antiderivative, and you write u to the negative 1/2. Multiplied by x, multiplied by dx. We have made one substitution. Questions?
So 3x squared plus 5 to the negative 1/2 is u.
No. 3x squared plus 5 is u.
Is u. Okay.
So in place of 3x squared plus 5, I have written u. 2 points for Nathan Rimler. Questions? Please.
Will you ever have multiple substitutions?
I don't recall it ever happening for our class. Not saying that it couldn't happen, but not for what we typically do. 2 points.
And you're putting in the 3x squared plus 5, not the 6x, right? Because just u and not.
It's all about equal. What is u equal to?
It's equal to 3x.
Right, so I can't put 6x. That would make no sense.
Would you ever put 6x in like this, or you always just put
So
u?
this is kind of I'm pushing you a little bit, so don't be offended. How can I put this in place of, like, what mathematically says that can be put in place of
How
u?
dare you? Just kidding.
Like nothing. It doesn't say u equals that. See what I mean? Like it has to be equal. Look, sorry, you hit a sore spot. My theory is that literally hundreds of millions of students across the world spend 11 years in math classes and they never learn what equal means. Like all they want to do is follow the teacher. Like, well, the teacher did this, so I guess I do it. Like, why? Like, I'm only doing this because equal means the same. So I am absolutely confident this is legal because equal is the same. Don't do stuff just because I do it. Like, find out why I did it. It's a good question. Anybody else? Give Lucas another, but 20 points for 1 day is pretty good. Okay.
Is that
Oh.
a 4?
You, sorry.
So all
Are you
we've
good
done
there,
is-
Lucas?
Yeah.
Okay. No, that's, yeah, it's kind of hard to tell.
So all we've done is rewritten 3x squared plus 5 is u.
So far. But look, Nathan Rumler. Actually, go to Liza. We need to make a replacement for this because we want to get rid of every x, forget about the x, make everything about u. Simon.
Do you always go back to these rows after you put a u?
We are headed for the rules.
So for that part, do we look for
You can't, this doesn't fit the rules either because none of the rules say u and x.
for the x dx?
Yeah, we got to get rid of the x dx. Like it doesn't match the rule. The rule says x to the n, x says x to the n dx. It doesn't say u to the n x dx. So Eliza, is there any way to create, using the equal sign, this particular item? This is why we took the derivative. Look over here. Okay, du over dx, you may have forgotten, means du divided by dx. It has always meant that. So is there any way to use algebra to rearrange that equation to create this particular item? Eliza? We definitely want to move the 6. It's kind of in the wrong place. The first thing I always do is I multiply both sides by dx. If I do this, Eliza, what does the left half of the equation become? du. Eliza, what does the right half become?
6x dx.
Yep.
And then I divide by 6.
Yep. 2 points for Eliza. So back to Lucas de Mordaunt. Lucas, is there any equal sign on the board that now is helpful?
Yes.
Which one?
The one that du dx equals 6x. Oh, wait, we just used that.
We used it, but that's not the one that's helpful at this moment. 2 points. Who can see it? What equal sign is helpful now?
Can we substitute the 1/6 du for the 6x?
Equal means these are the same. So here's a purple box right here, 2 for Liza. Here's the same purple box. And here's a different box, orange. But equal says they're the same. So I don't have to write x dx anymore. I can write 1/6 du. So this now becomes, equal sign again.
du or
What is du?
Du just means an infinitesimal change in u. It's not derivative. This is derivative. Derivatives are ratio.
Oh, like the graph.
Questions? All the pictures have been burned. We have no x. The x never existed.
No! I also have no X.
The X was all about themselves.
Wait, but now, do we know that U also equals 3x squared plus 5?
Don't do that yet. Got to stay with you. Don't, like, you've got to spend some time for yourself now. You just got to make it all about you.
Get that X out of here.
Get it out. Joseph,
Oh.
the 1/6, something we can do something with the 1/6. What do you think we can do with the 1/6? It's just like derivatives. When you're finding the derivative of something and one of the items is a multiplying constant, what can you do with the multiplying constant?
Take it out.
Take it out.
Take her out.
Take her out.
Yeah.
Oh, so we got a new
Take
one.
yourself out.
There you go.
Oh, wait,
Go to the
so
movie,
we're
man.
just
Buy some
deriving
popcorn.
As if it's like just a regular derivative.
Yeah, the rule's the same. Multiplying constant for integral versus antiderivative versus derivative. Will Perlis,
Yep.
right here. Does that antiderivative form match item for item exactly like with any of the blue rules?
Any of the blue
is-
rules? Well, doesn't it match the power rule?
Matches the power rule perfectly.
Yeah, perfect.
Nuh-uh.
Yeah.
No.
What do you mean a variable?
Oh.
Natalie, please.
It doesn't matter if it's your.
Gotcha.
It's the same.
So remember, the letters don't mean anything until we assign something to them. So I chose X because it's traditional, but I could have made every rule say Y. And it would say dy. I could have made every rule say W. Does that make sense? Yeah. So U's fine. Now, be cautious though, be cautious. Like right here, we can't have that. That's a mix of X and U. That's not going to match. But this does match. So Natalie, 1/6 is just 1/6 multiplying. This purple box is equal to something else according to the blue rules. What is this equal to according to the blue rules, Natalie?
U to the negative 1/2 plus 1 over negative 1/2 plus 1.
Plus 1 again. Plus a constant.
Yeah, plus C.
Questions? Please.
Back in the beginning, we had x dx, and we're trying to figure out what we should do with it. My first thought was to do the power rule, because it's x to the first base.
The trouble is this, Clara. You don't have the antiderivative of just x dx. So you're using an equal sign improperly. You have antiderivative of u to the negative 1/2 times x dx. So because it doesn't match, you can't use the equal sign of the rule.
Yeah, I thought it was like derivative, where it's like, you can do, it's like subtracting something, you can separate
Oh,
it.
pause right there. You're doing great. 2 more for Clara. Are these 2 items subtracting?
No.
So even with derivatives, we couldn't do them separately.
Yeah.
With derivatives, we have a rule, though. We have the power rule, which allows us to separate them. We have no such rule available to us in our class for the blue. 2 more. Very good. So, Grant, what's a quicker way to write this right here?
Negative 1/2.
Yeah, no.
Oh, 1/2.
That's better.
Can you just make it 1/3?
You're 1 step ahead. What's the better way to write the bottom?
Oh, 1/2.
1/2. Dividing by 1/2 is the same as multiplying by. Stay with me, Grant.
2.
Dividing by 1/2 is the same as
Two.
dividing by
Two.
0.5.
2.
Yeah, multiply by 2. So, that was rough. 1/6 multiplied by 2 multiplied by u to the 1/2
Wait,
Plus
no.
C.
plus a constant.
But then u equals 3x squared plus 5.
U is 3x squared plus 5.
So then it's
1/3
1/3. Oh.
3x squared plus 5 plus a constant.
C, because we just
1/2. Say 1/2.
plus C.
Oh, sorry, 1/2 power. So this would be square root word.
But in the answers, it's 2.
1/2 power. Either way.
Oh.
Sounds crazy.
Please, Natalie.
Why did you stop writing that anti-derivative?
I used the equal sign of the blue rule sheet to get rid of it. So what I did is right here, Natalie, This is an exact copy of what you see on the blue on the left side of the rule, correct? The other side of the equal sign, there is no antiderivative symbol and there's no du. So I just did what the rule said. Does that make sense? 2 more. Pretty good? Please, Simon.
I'm just wondering, when you change the u 1/2 to 1/2 to square root of 3x squared plus 5, does the 1/2 just go?
No, 1/2 power means square root. I replaced u with just 3x squared plus 5, but square root means 1/2 power. So 2 more. Pretty good? So now Lucy will help me here.
Thanks, Matt.
If I want to check this answer,
My goodness, how did I not see it before?
I want to check this answer. That's funny. I need to do ddx of this thing. So Lucy, how do I do ddx of this thing?
And C's a constant.
You do 1/2.
Good work. So the 1/3 is just a constant. We just write that down. We get 1/2.
To the square root of 3x squared plus 5. Times d of 3x, or 6x.
Nicely done. So the whole thing is, that's 3 points for that one. That was good work. So look, is this exactly the same thing we started with? Will, are these factors or terms?
They're all factors.
Oh.
Yeah, so I take 6 divided by 2 is
3
3 on the top.
on the top.
3 divided by 3 is
1.
1. Hey, look, we're left with x divided by square root of 3x squared plus 5.
It's a neat trick.
Question?
And dx just means like.
This was just part of saying find the antiderivative. Like you got to break it into pieces. Like right here, stay with me, Will.
Okay.
When I look at that, here's what I see. I see a formula right here in blue. Oops, I messed up. Sorry. I see a formula in blue. They're asking me to find the antiderivative of that formula. That's what the integral in dx means.
Okay.
So I did. The antiderivative of blue is yellow. Therefore, the derivative of yellow has to be blue again. Do you see it? 2 points. Questions? Claire, please.
Did we kind of disregard C?
We did not. C is definitely a part of the antiderivative, but it's just a constant like -3, so the derivative of -3 would be 0. Ready?
Will it ever have, like with these type of problems where it's like C of 2, or like does it ever say like C equals a certain number?
There will be cases where they'll give you extra information that will allow you to find the value of C. Natalie, please.
Why do you, like, because the one we did last time we didn't use U.
Right. Last time we just were able to use the blue rules. Like what they presented fit the rule right away. So there was no need for anything else.
So if it like just doesn't match that, so you have to start using it.
Correct. So if it doesn't match a rule, I try use substitution. If that doesn't work, I'm down to option 3, which is my last option for this class, which is think of some algebraic rule you learned in some previous year and hope that that will help somehow. They never have given a problem where you can't do it. It's just always one of those 3 methods, or kind of a combo of them. Okay, next thing, cool. Good work, stop the video.
So this one we had to do an algebraic thing to do use of.
Perfect. We had to do a little bit of algebra to get to where we could do a use of.